there's no such thing as root cause. What you call root cause is simply the place that you stop looking any further. On today's Taproot podcast, I've joined by Mark and Ken, and we are going to be getting into I'll call it the phrasing, the common phrasing that there's no such thing as root cause.
The argument,
the philosophy that there is no such thing as root cause. Now, I'm bringing in my two experts here to talk through this concept. Mark, obviously, writing the book on...
Doesn't get much more expert than that.
On writing the book.
It says root cause right there, right in the book.
And Ken, you're in here as our glamorous influencer. You had a video you made about viral posts that went about no root cause. So we're going to have a little bit longer of a discussion to talk about this topic, this philosophy topic of is root cause even a thing? And I think a good way to start a philosophy discussion is with a clear definition.
No, it isn't.
No, it's not?
No, it's not, because the people who say there is no root cause never have a definition of what a root cause is.
So let's get into this. We hear people talk about this. We've heard this phrase. I think it probably came up early 2000s is probably when it was first being published on. There's no such thing as a root cause.
Yeah, it seems to go in cycles where there's no such thing as a root cause. Some consultants throw that out there to get some thoughts in there, and then everybody realizes it's silly, and then it goes away, and then it comes back again. So it's kind of in that cycle. Yeah.
So I would say the first, at least sourcing I can find, is in early 2000s, and then I've seen the same argument repeated every so often. Mm-hmm. And it's by a different group of consultants selling something, if you will. But I want to get into the argument. So first, before we get into theirs, I want to define our side. What is a root cause? When we're talking about Taproot, we're talking about root cause. And Mark, you wrote the book. What is a root cause?
There's actually an article in our blog called The History of the Definition of Root Cause. And it goes through about 3 or 4 iterations on the definition of root cause. And it starts out with, I've actually printed the article out here. Ooh. And the first one, this is the way back in about 85, Dave Bush and I came up with this. It was the most basic cause or causes that can reasonably be identified and that management has control to fix. And that was way good back in the day. And of course, then we expanded on that, made it longer. And we said a root cause is the most basic cause or causes that can reasonably be identified, that management has control to fix, and when fixed, will prevent or significantly reduce the likelihood of the problem's recurrence. So there you get into fixing things as part of that definition of how far you go, to where if you can go to where you can find effective fixes for that root cause, then you've gone far enough. And then other people started getting in the game of defining root cause, and you'll notice the difference here. They said it's the most basic management system cause or causes that can reasonably be identified and that management has control to fix. So you throw in that management system stuff, which I never thought was really needed. That you could have a root cause that wasn't a management system cause, but you could have a management system cause too. And most of those management system ones were either under management system in the Taproot system or generic causes. And so then we started thinking really hard. And in about 2005, we decided we needed a totally new definition. And by totally new, you'll recognize how different this is. A root cause is the absence of a best practice or the failure to apply knowledge that would have prevented the problem. And that's a lot different than those first ones were. And the idea behind it is that, I don't want to say every accident we ever had, but pretty much most accidents, we knew how to prevent them. The how to prevent the accident was known. We didn't do it.
As a matter of fact, usually during the investigation, you'd go through it, you'd find these root causes, and everybody go, "Oh yeah, we knew about that.
We should have.
Oh yeah, we saw that before.
We should have. We knew for a long time that was a bad display, but we didn't fix it.
Right.
And maybe we won't now.
If it's okay now.
So you went through, we have this definition, missing best practice. Now, I
Right.
want to compare that definition to some of the people that have done writing about there's no such thing as root cause. What are they defining as a root cause?
Well, they don't define it.
Well, I'll give you one.
All right, go ahead.
So this came from an article I was reading. It was published back in, I want to say, 2006. Their definition of a root cause is a causal factor with no predecessor that is relevant for the purpose of the analysis. Whew. Now
I wonder what that means.
You have to think about
you had to
that.
define what causal factor. They did that too. Causal factor is a condition, action, event, or state that was necessary or contributed to the outcome of the focus event. Focus event being the reason you're investigating.
I'm still not sure what that is.
Yeah. So basically, it's a root cause would be the lowest level event in the chain of things that led to the event.
Or was it the
Incident.
first thing in the chain?
It's the nothing precedes it. It's
Nothing precedes.
Yeah.
That sounds like the first thing
I would
in the
think
chain
that
to
too.
me.
It was very unclear. See, when you get technical,
Is it the first or the last?
and therefore you get people that have really bad ideas of what root cause analysis is, and then they'll come in and say things like, root cause analysis doesn't help you because it's all cause and effect, and you're like, well, I think you've really narrowed your definition of what a root cause
Well, now
is.
you've made root cause analysis cause and effect.
Yes. So there's a couple different arguments that I want to get into them. The first one that I think is we'll call it the first straw man that I've seen as an argument, is they say there's no such thing as a root cause, meaning there's no such thing as a single root cause.
And therefore, they define root cause analysis as finding a single root cause.
Yes, so that's a common one that they put in. They say it's a single root cause. And there's a famous example. It comes from Sidney Decker's Field Guide. And he said the way to prove this is, and he always called it, he said a root cause was something that we construct. And his example was he had an airline that crashed into a mountain. So they had an airplane that crashed into a mountain. And there were two investigations done. One was done by the owner of the airline itself, basically the pilots and the people that owned the plane, and the other was done by the Civil Aviation Authority, who had responsibility for the what is it called? The traffic controller and the system behind that. So both of them were investigating this, and the Civil Air Authority said that the air traffic controller did not play a role in this, and it was the pilot's inadequate use of automation that was the root cause of the incident. And the airline, they said that there was no standard phraseology, inadequate language, and inattention by the controller, in that inadequate automation database and a lack of radar coverage over the area that led to the issue. So it's both ones are pointing to the other and saying it's the other person's, the root cause is the other person's fault.
Well, this is the whole blame argument.
Yeah. So his thing was saying, well, in this case, they both could be right.
But they can't be exclusive.
Yeah, it's like, well, that means they're both. If this one's right and this one's right, it means they're both wrong because they missed this other thing. And his point is that there's multiple system causes for an incident, and therefore root cause analysis, singular root cause analysis, misses that because it's looking for one problem. Now, what do we see? How do we feel about this multiple?
Well, let me make a comment first.
Go ahead.
I saw one guy give a talk once where he finally said at the end of the talk, there's only one root cause for anything, and it's original sin. Because after original sin, humans started making errors.
There you go.
And so,
Boy, that's digging back pretty far.
That's going back pretty far. That's pretty much the beginning, like that definition said.
It is.
I don't think that's going to help anybody
No,
much, though.
I don't think you're going to fix that.
No.
So no correct.
So how do we approach the idea of, is there one root cause?
Yeah, I always think to myself, it's our companies that we work with are pretty smart in general. And we don't allow ourselves to have single point failures in most cases, right? We put things in place, safeguards in place, policies, all these things are put in place to ensure that a single point doesn't cause a massive failure. So when you do a root cause analysis, it's rare that you're going to find a single thing that caused the problem, because we're we're smarter than that. We've put things in place. So there's almost always. In fact, I'm tough to find a time that's not true that you don't have multiple things that allow a problem to occur.
I would also add to that anybody who gets in the argument of which is the rootiest root cause is also making a blunder, because what you decide is the rootiest root cause, or the one thing you're going to fix, versus the 6 or 10 things you found. You're fixing one thing that you think would be the best thing to fix for this incident, where incidents in the future probably won't happen exactly like this one did. And so you want to try to fix as many things as you can. I'm not saying fix everything, but if you have several things you fix, you once again have redundant barriers that are now stronger, and that'll help you have less future incidents.
Now in Taproot, there's 4 things we have people do to go through the process of finding and fixing problems. We make sure that they gather the facts and information, build out a snap chart. We have them identify causal...
Which means you understood what happened.
You have to understand
all the things that happened.
We have them identify causal factors, where the system broke down, where errors occurred.
That's right.
Right? Where the system failed, and that led to the incident. That's the causal part of it. It's actions or lack of action that led to the incident. And then once we know those, we look for those missing best practices that could prevent those errors. Those are our root causes. And then we write better corrective actions
against those root causes,
and
not against the errors.
Well,
right?
or it could be against not just the root causes, but it could be adding additional safeguards,
sure,
or making those safeguards stronger is what it usually ends up being.
So long before these books were written in the 90s, long before that, so these books were written in early 2000s. Mid-2000s. In the 90s, we already had a process to identify multiple root causes, because we recognized that a causal factor being a mistake, error, equipment failure, there could be multiple best practices that you could apply. There's multiple things that you could do to make that error less likely, to make it where people are less likely to make that mistake or take that action. Right? So we don't see it as root cause being it's a singular thing. It's what are these multiple things that we could do that would make this specific type of issue, equipment failure, human error, something like that specific issue, be less likely to occur. And so we cover that with missing best practices and looking for root causes as a way to identify how to fix that and prevent that error in the future. And so I think that's one of those early differences, because a lot of these people that see it as a singular root cause, they don't recognize that it's not the mistake that you stop at. We're looking for what's missing in our system that would allow that mistake or encourage that mistake or set people up for that mistake. And so that's where Taproot, again, I think is different.
And that's, again, where a lot of the blame type root causes come in. When people talk about, that root cause is a blamey kind of root cause, the reason for that is they're not getting to root cause. They're getting to the errors, which
they're getting to blame.
Really, they're getting to blame. That's as
their
far as they
objective,
go.
is to find blame.
Yeah, our point here is to point our finger at somebody.
And that was part of your example, Alex. The Civil Aeronautics, whatever it was called, wanted to blame the pilots, where the pilots union wanted to blame the what was it? The control
system.
Yeah.
Right. Everybody wanted to blame someone else.
And you see that a lot. That is a blame-oriented system, and you see that a lot because people start looking for who's to blame rather than what happened.
Right. And in neither case are they getting to root cause. They're getting to the blame.
Yeah, they're just, and I generally think of it as if your root cause analysis is just looking at who made a mistake, you're not actually doing root cause analysis. Maybe I would call it, if you said by Taproot definition, that would be like causal factor analysis, but you can't stop at the causal factor. At best. It's really probably even a less.
Well, because okay, let me go. I was in a place once, and they were pretty blame oriented. And it was funny because the guys doing the investigations learned that if they found somebody made a human error, that guy was going to get punished. So they stopped looking for human errors and they started looking for equipment to blame, because if the equipment was to blame, then nobody got punished. And so all these incidents started having all equipment causes and nobody made any mistakes. And I thought it's like, well, what happened here? Why did this happen? It was because they got tired of being the bad guys and people getting disciplined, and they were at fault, and they just stopped finding people at fault anymore.
Yeah, and you didn't want to ask the question like, the equipment ran into the thing. You didn't want to ask, did we pilot it into there? Was this a program, or is this don't ask the human side of it. This kind of leads me into what I would call another common critique of root cause analysis. And this comes from they talk about common in, we'll talk safety 2. So one of the comments between safety 1 and safety 2 is they talk safety 1 is very causally focused, right? Causality. This one, they coined the term causality credo, being adverse outcomes happen because something goes wrong, and this allows analysis to reason backwards from consequence to the underlying causes. It's all about causality. So this bad event, and we want to go backwards. And they say root cause analysis is only focused on the bad. Your RCA only focuses on the rare events, the rare things that align together, and it misses all these other times because we're just focusing on when things fail. So a common thing that they look for is they look at using investigations to look at what went right, as opposed to RCA only looks at what went wrong, which is a very narrow. So if you looked at like the bell curve of how work happens, most of the time everything succeeds.
I want to do a Rickover quote here. Rickover quote says, "You learn nothing from success. You only learn from failure." Yeah. I thought that was a good quote from Rickover.
Well, I remember...
And unfortunately, I've been influenced by him.
I remember I went to a HOP conference, and I came back and did a little presentation on what I got out of that conference. And one of the things was I had a beta slide of a comparison quote. And one of the sides was that Rickover, success teaches us nothing, only failure teaches. And the other side was, you learn learn very little from failure, but success has everything you need to know of what to do, or something like that. It was like a comparison of two quotes. So I think there is...
Let me put this a different way. Success may have happened just by luck. However, failure hardly ever happens due to luck. Maybe bad luck, I'd say.
Maybe.
So I think the argument typically is that RCA is backward because it only looks at failure, and the majority of the time things are going right, and you can't learn what you did successfully by looking at what you did bad or did poorly. And it's difficult to see the things that make you successful. It's easy to see the things that make you fail. I think that's the argument.
I think part of the issue with that is that when something goes wrong, it's rare that there's, again, we talked about this earlier, that there's a single thing that went wrong. So if you are waiting for an incident to occur before you go do an analysis, that's kind of true. But if you go look at when you don't have an incident and go analyze that, you're still going to find problems. And if you can fix those problems before they actually cause an incident, you don't have to wait and only look at that narrow time when an incident occurs and analyze the bad stuff. You can look at when stuff didn't cause an incident, but there's still problems there, and you can still fix those. They're little failures that happen.
So in other words, even though the outcome was success, the process may not have been a success, and you can learn from what went wrong, but didn't, because of some other safeguard that saved you, didn't become an accident or an incident, and yet those problems were there to be found and fixed, even though they didn't cause an accident this time.
And there's nothing wrong with strengthening that good safeguard that saved you. That's great, but there's an awful lot of opportunities there to fix those little issues that maybe this time didn't cause an incident, but sure could have.
And I take this back to kind of what we teach, which is being proactive. And when you're doing proactive taproot, you're going to look at your system and you look at all the things that you expect to happen. Did they happen? And when things didn't happen as expected, did these safeguards work? And so identifying safeguards that worked, you don't want to break those. I don't want to break safeguard that works. I want to fix safeguards that fail, and I don't want to break safeguards that work.
Were you going to bring up work as imagined versus work as done?
I wasn't, but we can.
Well, because I think that's another major fallacy. that operators are just out there and no work can be pre-planned, and instead they just invent ways to do things on the fly, which are always the best way. And the fallacy is that somebody could sit in a room someplace and design how to do a job and it would ever go the way they thought. And that the systems are so complex and so, what is the word they use for non-understandable? They have a word for that I can't remember. It's a PhD word. And so you can't understand these systems.
Almost chaotic. Is that
well, yeah. And
it's complex.
It's sort of a combination of those. And that only the operator on the fly can make these decisions. So that it's sort of like, if you ask me, it'd be like saying, oh, well, flying a plane's really complex. We can't write down how to do that. So pilots, just go out there and take off and handle it till you land.
And good luck.
Good luck, because you're going to be smart enough. And if you're not, you'll die.
Yeah, and you should be there if you're not that smart.
I think the argument generally ties back to, your human capital as a safeguard is so powerful at identifying and correcting abnormalities in systems. And they have to deal with this complexity where something that's different and abnormal comes up, and they're going to know what to do. I think from our side, it's always when we talk about complex systems and knowledge-based systems, somebody has to take a knowledge-based decision. How often is work really knowledge-based? Not how often do we make it knowledge-based.
That depends on how bad your procedures are and how bad your
work
planning
direction.
was.
Yep.
Yeah, so it's. I think a lot of the times this idea of complexity comes from that, and that's one of those other commonly critiqued root causes, is the idea that cause and effect doesn't work in complex systems. That you can't do cause and effect analysis. You couldn't look at causality in a complex system. So I'll take the example that we're tying in here. We do an airline one of a pilot, and we're trying to analyze multiple decisions being made by a controller, being made by a pilot, being made by a co-pilot, and we have all these people making decisions as this event is happening. That's so complex. You could never capture that with a 5 why. That would be their argument. You couldn't have that be simple.
I don't know if I'll disagree that you couldn't capture that with a 5 why. I think I might agree with that. That's why you don't use 5 why as a root cause analysis system. It's too simplistic. It never gets you past that single root cause that we talked about earlier. It goes in the direction. If I'm a training guy, I end up with a training corrective action, training root causes. That's just where I end up. And that's the problem with equating root cause analysis with 5 whys. They're not the same thing, and you're limiting yourself if you say, oh, you're doing 5 whys wrong, therefore root cause analysis doesn't work. That's not the same thing.
The example you're doing is a pretty famous example, and it is a little older because they were coming down to land at an airport in South America, and I think it was in Colombia, but I'm not sure. I think it was in Colombia. And they're coming into land, and it was an American Airlines flight. And what a pilot would say is they were behind the power curve. They thought they were going to go around and come in a different way, but they were behind schedule, so the controller said, well, you can come in directly if you want and save, let's say it saves 15, 20 minutes, and would get them on the ground on time. So they decided to do that. So when they decided to do that, they then had to reprogram their little flight computer, which was by punching in numbers. It wasn't some kind of graphical user interface, right? They had to punch in little numbers, and the guy, either he punched the numbers in the wrong order or he punched in one number wrong. And instead of taking them straight in, it made him do a 90-degree bend. So when they hit the button that said,
go
fly, the plane starts going off to the side, and the pilot says, why is it doing that? And the guy goes, well, I don't know. And they got really focused in on why the plane was doing what it was doing, and they didn't realize they had turned in between the mountains now. So all of a sudden they decide, this is wrong, I'm going to take control, and I'm going to fly back to where I'm supposed to go. So they, try to steer back to where they were going to go and ran right into a mountain.
And there's a mountain there.
There was a mountain, and now none of their displays in those days showed what the ground contour was. There wasn't this pull up, ground, whatever they call it, warning, and all that stuff. That all didn't exist back then. And Of course, the controller didn't think they were going to fly off at a 90-degree angle. That wasn't what he told them to do. And he didn't warn them, hey, by the way, if you try to turn now, you're going to hit a mountain. So there was lots of things that went wrong, just as you normally say. There was lots of causal factors or lots of things, mistakes that were made. And there were lots of reasons for those mistakes, reasons being root causes that you could fix, including some things you could go back and apply advanced technology now that I'll say it may not happen because of the interface there in the cockpit having better displays, the warning signals being better, and maybe being even easier to program things so that you aren't just punching in numbers and if you get one wrong, the thing's going to make a 90-degree turn. So all those things can make this not happen. But when you start blaming people, all that's out the window. It's the pilot's fault. They didn't put the numbers in right. It's the controller's fault. He didn't tell them hey, you're going to turn into a mountain if you make...
Now, to me, that doesn't sound too complex to analyze.
It's not.
But
it was interesting. Very interesting incident, though.
Yeah. But I think a lot of people look at root cause analysis or look at investigations, and they find all these complexities and they want to show that complexity. I shared recently with the group, there was a presentation done at a conference, and it was on the FRAM model. And all I get out of that model is, boy, that makes things look complicated. And I've seen a lot of the people that are saying, don't do root cause analysis, it's too simplistic. They're talking about typically 5 whys. We need something that shows complexity and helps display this complexity. And that's kind of the, we'll call it the PhD side of this, right? There's a PhD side to how they approach the academic for how do we take into account the social complexity of rules and
socio-technical systems.
How do we handle those? I think for us, it's just about showing what happened. So with us, we do a snap chart, and you can plot complex things because you can have multiple people taking actions. And yes, if there's a lot of people taking simultaneous actions, it can look a little complex, but it's still very much ordered in time of what is happening.
Right.
And I think even with complex systems, if you order things visually in time that they happen, it doesn't look as complex. And I think we recognize there's actually not as much complexity in work as we imagine there to be. Everybody that I've talked to, they're like, oh, our work is so complex and so unique and so different. And it is that you're doing something unique and different as a company, but typically your work is very straightforward and very linear because we exist linearly as people. So if humans are involved in the process, it's going to be a rather linear process. Now, there can be some complexity when we start to add things like chemical interactions.
Sure.
And when you have what you'll call variables that you don't see, right? If I can't see a variable, it might feel like it's complex. But I think that comes down to what we had talked about with human interface, right? If I can't see that there's a mountain next to me, it's dark and I don't have any...
Dark.
It was dark.
It was at night.
And I don't have this radar system that shows how far away from...
And there were no lights on this mountain, so
Yeah.
it was just a black thing out there.
In the black sky.
So if I don't have a technology that gives me that input, well, I don't know there's a mountain there.
And it feels complex now.
And it feels complex because how would I know that there's a mountain in the dark? But in reality, it's just we either have not made those variables visible when it's possible to make them visible, or we've chosen not to show somebody something. I think.
Well, that's a really good example with the 737 MAX crashes. I don't want to talk all aviation accidents here, but that's one where they chose not to train them, and they chose the system. What the system was doing, they had no idea why it was doing it, And it was really taking over control of the plane, and they couldn't recover, and therefore 2 planes crashed before they decided, this probably is a bad system. We probably ought not to do that this
Yeah, their
way.
initial thought was that the system will just handle this. And,
Yes.
and we don't have to train these guys to know this. It's just too much data. They don't need to know
Well,
this. It'll just
And
work.
it costs money to train.
It costs
then-
money to train them, so we don't have time to do that.
Exactly.
And the system will just handle it. The
Yes.
system is good enough, it'll handle
So
this.
I want to go back to something. Normal accidents. You ever read the book Normal Accidents?
Yes.
The whole idea behind that was there were some systems that were so complex that it was going to be normal for them to have accidents. And one of those systems was nuclear power. And this was written, it was after 3 Mile Island. So that was I don't think it was, it might have been written before. Yeah, it was written before Chernobyl, but after 3 Mile Island. And his basic conclusion is, yes, if you got really smart people, had really good procedures, did everything right, you can run a nuclear power plant and not have an accident. But you're investing so much into that it's not really worth it just to make electricity. And so there's some systems you should say, we're just not going to do that because it's just too accident prone, I'll call it, because of the complexity of the system and the standards you have to set, the operational excellence you have to achieve to not have accidents, that it's not worth doing. And so nuclear power was one. Nuclear weapons was another one. We just shouldn't have those because we're gonna have nuclear weapons accidents, and sooner or later that's going to kill a whole bunch of people. And
biological labs.
There were
gain of function would be a recent one. Gain of function research.
It wasn't in his. It wasn't.
That wasn't in his,
book,
but that would be a modern one.
Maybe a good example.
Another common modern one that's brought up right now would be artificial intelligence.
AI.
Oh yeah.
Artificial intelligence would be one because they say, look, if you're not doing, if there's a point where you have AI that is smarter than people and can instantly replicate itself, you will have a problem. It's going to be inevitable because it's going to be smarter than you and be able to get out there and replicate itself before you can do anything about it.
Well, it thinks it's smarter than you anyhow.
Yeah. So I was listening to a thing that was talking about that. There's realistically, everybody that's working with AI should be doing it in a
enclosed.
It's like
cut
an
off
enclosed system,
Yeah.
and
It can't get out.
and that way it would be very enclosed. And it's like, yes, we should take the thing that we're going to make smarter than us and confine it and torture it in a box. that'll totally work. That's definitely not gonna cause any problems in the future.
Well, the point behind all this is, I want to talk engineer versus PhD.
Yeah.
All right. And I got a master's in engineering, and I could have got a PhD in it, but the idea is if you're a PhD, the more complex things are, the more research you can do, and the more things you can write. And you want to see the world as so complex that only you can understand it, or at least you need to coach these poor peons out there that are running the real world. Because not everybody running the real world has a PhD, and not everybody running the world has these complex thoughts about how things go. In fact, if you're running the real world and you're trying to have complex thoughts, you're probably not going to have time to do what you need to do to run things. So engineers tend to simplify things. We don't go back to quantum mechanics to start designing things. You have engineering rules and laws that are simplified, and those are good enough to make working systems. And if we didn't do that, all the things we take for granted today would not exist. So whenever somebody tries to make something so complicated, let's say root cause analysis, that you say, well, you normal people, you really can't do this because you have to understand socioeconomic technical systems and all that stuff. And you start talking about there is no root cause, we can only look at positives, blah, 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 blah. And it just really is making things needlessly complex rather than saying root cause analysis is needlessly too simple. And by the way, if you don't define root cause, you can make a straw man that says, these idiots out there are applying this stuff and they only go to find blame, or they only go find human error, or they only find one root cause, and you use this as your bad example, and then your good example is whatever you're thinking is better. And so you always use the straw man bad example and not a really good system to compare to. Because if you used a really good system, you'd find you had a lot more in common with them than you had differences with them.
Now, the last topic I want to jump in on with this, and I think that's a perfect lead into this. We talk about PhDs make things seem more complex, engineers make things simpler. One of the things that is a common critique of root cause is that it only shows you what you look for is what you find. So they have what you look for is what you find in root cause analysis. You're only going to find what you look for. You're only going to find what you know.
Yep.
And if you don't know human factors, you're not going to ask questions about that. You're not going to know these things to ask to get into this. You don't know the right questions.
And that's true of unguided systems. Well, systems that don't give you any guidance and just allow the human to go, I'm an investigator, I know things.
But that's an assumption.
That's right. That's an assumption that you're making, and it's when you're limiting yourself to unguided systems that are all.
Five whys.
We use 5 whys as a great example of that. If that's your example, if that's what you are considering when you're saying that, hey, we're only going to get to what I already know. Well, that's true. It's because you haven't properly defined what a good system is.
Oh, it totally is guided. It has a fishbone, and there's
No, that's
different.
fishbones. That's not 5 whys.
Well, no, but you do the fishbone, and then you have the 5 whys under each bone. It's
Now you
great.
get,
Look
now you
at-
get
look at
two
that.
things. That's getting
Oh,
complicated.
all right,
right there.
PhD. Let's not get too complicated here.
So I think when they say, RCA doesn't help you look at these different things. Again, I agree. They're creating this straw man of what RCA is, and with Taproot we are different than that. We're an expert guided system. We're not bias based. We're not based on your knowledge and experience or what you want to find. We give a series of human performance expert questions. It's going to make sure that they're looking at things like fatigue, training, procedures, work environment, equipment, and how people interact with them, looking at things like team performance and management systems.
And not just looking at those, but looking for evidence for those. That's the other piece of it, is that not only can I say, yeah, I think there's a training problem here, but well, where's your evidence for that? It's you have to have an evidence-based system that when you get to what you say is the root cause, there's got to be some evidence to back that up. And if you're just out there saying, well, I'm a training guy, I'm going to find training problems, that's not going to help if there's no evidence to support that.
And so I look at Taproot as we have a great process for teaching people how to understand what happened, gather evidence, make it easy to see what you know about the incident, and we have a really good process for giving people the right questions to ask. So all they need to do is be curious and thorough, and they're going to get a great investigation. They're going to really understand what happened and what they need to do to fix it, because they're given the questions and they're given an easy process to follow to gather the evidence they need to answer those questions.
I want to say one thing. A lot of times people say, well, root cause analysis isn't good because it's not perfect. And they have some imaginary perfection in their mind that they think is good problem analysis, since we can't say root cause analysis for them. But maybe it's success analysis, whatever
Good
it is.
learning opportunity.
Whatever it is, it's a learning team, whatever it is. They have in their mind what good is. And that's because that's what they're looking for, is what they find. And everybody finds what they look for. I mean, it's impossible. If you said, well, we don't know, whatever, we don't know about aliens, and now we're going to find aliens. Well, no, if you don't know about them, you're not going to find them, right? It's if there's something you can't understand, it's sort of like those little, what do they call those Tic Tacs that they were, Navy ships, fighter pilots were finding?
Yep.
Tic Tacs, was that what they were called?
Yeah, I think so, yeah.
And nobody can understand them because they violate the laws of physics. They go underwater at a speed that's faster than you should be able to go through the air. And they're saying, well, we can't understand this. And maybe it's real, maybe it's not, maybe it's a figment of somebody's imagination somehow, but it's really hard to understand if you get something that's really beyond your understanding. So what a good root cause analysis is it takes what you can find, what you can do, what normal people can find, with some guidance from a system that helps them expand what they're going to look for, so they have a bigger then their little, I'm a training guy, I'm going to look for training problems, it gets him further out. It may not make perfection, but it makes it much better than what they would have had, and it gives them good, effective corrective actions to improve performance. And that performance improvement, instead of saying we're going to get perfection, we're going to get better. And if we constantly get better, we'll have less accidents, we'll have less incidents, we'll have better operational excellence, we'll have a better operating plant, and we'll have a less likelihood of a major accident. And that's what you're looking for. You're not looking for perfection. You're not looking for a PhD study. You're looking for practical things that you can apply every day to get better.
And you told me this, we were talking about, a perfect investigation, and you're like, at the end of the day, people that come into our courses, when they leave, they're going to be better, and they're going to do better investigations when they leave. They're not going to be perfect.
I don't know what perfect is.
Yeah, we provide resources to help coach them and be better, even after they leave.
Consistently better.
Not
just sometimes better, but consistently better.
And
right?
and we know that they're gonna be better, but it's a journey. And a two-day class will not turn you into an expert.
What I knew in 1985, I know a lot more today.
Yeah.
So my idea of a perfect investigation today is way better than a perfect investigation I had in 1985. But my investigations in 1985 were better than the ones that were done before that. So there's always a constant learning curve. There's always continuous improvement, both in the root cause system and in the way it's applied, and in the goodness people get when they apply it. So that's I think this fallacy of perfection doesn't exist.
And certainly making it more complex is not going to make it necessarily better.
Right.
Might even make it worse.
It makes it ununderstandable for lots of people.
So if somebody wants to learn how to do root cause analysis, they've been convinced it is a thing. It does exist. And
there is more than one root cause, and we can find them.
And in fact, maybe we can find them simply. If they wanted to learn that, what would be the best opportunities for them to learn?
Well, I always think for people who want to get good at it, the 5-day course is what they ought to go to.
Yep.
If you don't have a lot of time and you just want to dip your toes in the water, the 2-day or 2-day on-site or 2-day public courses, or the 3-day virtual courses are a way to dip your toes in the water and not spend a whole 5 days to get started. I hope that after you take the 2-day or take the 5-day, you'll go, gosh, I want to learn some more, and you'll end up going to the 5-day and really get better. Then if you want to really become an expert, you start going to the summits, and you learn lots of other, we go beyond just root cause analysis to lots of other techniques to improve performance, lots of other best practices that people share, and how people get better at improving performance.
So they can find out information about our public courses at our website, taproot.com. You can find information on our store page. Those links will be down below. We look forward to seeing you guys at a course soon or at the Taproot Summit to share information and best practices. If you disagree and you want to state why you think root causes don't exist, post a comment down below. If you have...
if you agree.
If you
want to
agree,
have a better idea of why you agree than we had.
and you have even more evidence to share of why root cause does exist, share your comments as well. We're always looking for continuing the conversation down in the comments below. Hope to see you guys at a public course soon or at the Taproot Summit, and we'll catch you at the next Taproot podcast.